Okay, let's talk about these radicals. So we've gone through the directions, hopefully you've gone through them on your own. I'm going to show you how this works. Okay, when I look at this, I want all my squares in the front and I want all my non-squares behind. Okay, this is what we're doing every single time. I want you to think of this as the square root of 25 times the square root of a. That's really what we're thinking here. Okay, so if I have this as the square root of 25 times a, I can actually split this radical into two separate parts. Okay, the square root of a product will be the product of the separate square roots. So I'm going to put 25 here because it is a square. I'm going to put the a here because it is not a square. So what I've done is I've separated the squares from the non-squares, the haves from the have-nots. Remember, this is the VIP. VIPs go up front. The rest of us common folk go behind. Square root of 25 is 5. The square root of a stays the square root of a. Okay? Let's look at this one. The square root of 8. Think of it. 8 is not a square, but are there numbers that multiply into 8 that are squares? And immediately, the only one I can think of is, 4. So let's try 4. And if I look at my handy list of squares, remember, oh, there it is. So 8's not on this list, so I can't leave it at that. So one of these numbers should multiply by another number to make 8, and it's this one. So the square root of 8 times 2 is the square root of 4 times 2. 4 goes to the front. It's a VIP. It's a square. The 2 stays behind. The square root of 4 is 2. The square root of 2 is the square root of 2. Okay. Now let's look at this another way. Another example. Okay. My negative comes along. I'm going to split this up. M squared is a square. It's good. Now let's look at n cubed. N cubed is not a square. N cubed is not a square because it has an odd exponent. So what I want to do is think of the number that I can take out of it. The biggest even number that I can take out. Because remember, you try to break this up into its products. Think of it as n squared times n to the first. There's a square. So there we have it. We're going to bring down the m. I'm going to put my squares here and my non-square there. So we get negative mn times the square root of n. Okay. Boy. Let's see if we can break this up. 50. 50 is not a square. But what number divides into 50 that is a square? Well, I see the 25 right there. So let's use that, shall we? So we're going to take 25 times 2. Is a cubed a square? No, but a squared multiplies to make a cubed, and it's a square. So a cubed is a squared times a to the first. What about b to the fourth? B to the fourth is a square. Okay, so now I'm going to break up these radicals. All right, so here we go. The square root of 25 is 5. The square root of a squared is a. Ooh, square root of b to the fourth is b squared. And then we're going to leave the 2a in the radical. All right. Number 5. Okay, I'll refer to my chart. 90 is not a square. Do you see 90 in the list? No, 90 would go here. And it's between 81 and 100. It's not in my list of squares. What number divides into 90 that is a square? 45 times 2. Yeah, 45 times 2 does make 90. But is 45 a square? No. Is 2 a square? No. Well, 90 is also 9 times 10. So let's write it that way. We're going to write 90 is 9 times 10. And again, y'all, we're making our line. We're moving our VIPs to the front. We're moving our common to the back. C to the fourth, is that a square? Yes, it is, because it has an even exponent. Is D to the fifth a square? No, because it has an odd exponent. But I know that D to the fifth can be created by D to the fourth times D to the first. And then what about E to the sixth? E to the sixth is a square. And there it is. Okay, so now we're going to break this up into pieces. The square root of 9 is 3. The square root of C to the fourth is C squared. The square root of D to the fourth is D squared. The square root of E to the sixth is E cubed. This goes nowhere, stays in the radical. All right, let's look at this next one. Negative 80 times Z to the 16th. Okay. 80, okay. 8 times 10, yes. All right, is 8 a square? No. Is 10 a square? No. So while 8 times 10 does produce 80, neither of those terms is a square, so we can't use 8 times 10. Now, you're going to say, how about 4 times 20? And I'm going to tell you yes, but I'm going to say, think of something bigger, and I'm going to go to 16. And I'm going to show you why. This is really 16 times 5. And then Z to the 16th has an even exponent, so it's a square. So we'll get the negative of the square root of 16. And what's the square root of Z to the 16th? Z to the 8th. And this is going to stay in the radical. Okay? You're going to say, okay, that's great and all, but how does that help me? Well, I'm going to show you why you would want to use that instead of using 4 times 20. Remember, our goal here is to simplify. So if I want to simplify this, I'm going to use 4 and 20, just so you can see. So this is 4 times 20, and this is Z to the 16th. So we're going to break this up into a square times a non-square. The square root of 4 is 2. The square root of Z to the 16th is Z to the 8th. We get square root of 20. You're going to choose this as your answer, and it's going to be wrong. Or if this were a multiple choice situation, you're going to get this answer and realize, oh no, none of these is my choice. Okay? Because 20 actually breaks down further. It's got a square in it. It's 4 times 5. So you would have to do a few more steps and break down 20 even further. It becomes the square root of 4 times the square root of 5. So this is negative 2Z to the 8th. The square root of 4 is 2. The square root of 5 is the square root of 5. And now we can multiply these two numbers together. And we get negative 4Z to the 8th times the square root of 5. And that is the same answer that I got there. But look how many steps it took, y'all. Really, think about it. I can either go through my list of squares and find the biggest, or I can just kind of work through until I get to the end. Do I care which one of these you use? Absolutely not. Do I care that you use the right process to work your way to that answer? Absolutely. Okay. I don't know how to find my squares. Well, I'm going to show you another way to do each of these problems, and you may like it better, but let me finish these. Okay, when there's a number outside, it's just being multiplied by the radical. So think of this. 3, I either bring it down or I break it down. That's my favorite thing to say in algebra. I can't break this down any further, so I bring it down as a 3. I can break down the square root of 9. The square root of 9 is 3. So here we get 3 times 3 is 9. Okay, here's another one. I'm going to take 5 times the square root of 32. 32 is 4 times 8, and I can write that. But remember, 8 can be simplified. So let's go bigger than 4. let's go 16 times 2. So this is 5 times the square root of 16 times 2. So this is 5 times the square root of 16 times the square root of 2. I bring down the 5. I break down the square root of 16 as 4, and I just bring my radical over. And now I multiply. 5 times 4 is 20 square roots of 2. All right, let's look at this one. Bring down or break down? We bring down the 10. We break down the square root of 200x squared y. 200 is not a square, but it does have a factor of 100 in it, and 100 is a square. 200 is 100 times 2. Is x squared a square? Yup. So he's a VIP. Is y a square? Nope. So he goes to the back. So from here, I can actually break up my radical further. I break up my radical into 2 parts, my bad. Okay, there's no difference from here to here, except I separated the squares from the non-squares. And from here, I bring down my 10. I break down the square root of 100x squared as the square root of 100 is 10. The square root of x squared is x. Nothing happens here. It stays in its protective little bubble. And then from here, 10 times 10x is 100x. And then the square root of 2y goes there. Okay, if you like squares and you know how to use them, that's great. Please use them. But I learned another method last year from some of my students, maybe from another teacher, and it worked out really handy, and some of you may like this. Okay, so remember I taught 8th grade math before, and one thing I learned is as our 6th grade wing was at the beginning of the wing, and then when you work down to the 8th grade wing, I got to see all these beautiful factor trees that you learned in 6th grade that our 6th graders made. So I'm actually going to use that here. I'm not going to mess with the variables so much as I am with the coefficient, okay? So if I make a factor tree for 25, I know that 25 is 5 times 5. So I'm going to break this down into its prime factors. We get 5 times 5 times a. All right, here's how square root works. If there is a pair of numbers in here, one of them gets to come out because it's been squared. Remember, what number is squared here? 5. So remember, that leaves the radical. We take that square root, and then we're left with the leftovers. I think I just confused myself, but let's see what happens with the next one. The square root of 8. Okay, I don't care about what numbers are squares or non-squares. I'm going to break this puppy down to its prime factorization. 8 is 2 times 4. 2 is prime. 4 is composite. So we break this down further to 2 times 2. And there they are. So here we go. This is the square root of 2 times 2 times 2. Okay? Here is my pair. One of them comes out because it is a square. And this poor little radical stays in. Number 3. There is no prime factorization, but I'm going to do the same thing here because I want to get you to understand that a square is a number that is multiplied by itself. So if you see values being multiplied by themselves, you know that those are the numbers that get to escape the radical. So m squared is, oh, come on, Robadeer, fix yourself here. Okay, this is the square root of m squared n cubed. Okay, m squared is m times m. N cubed is n times n times n. Okay, do we see any pairs? There's a pair here. There's a pair there. Because they're a pair, because they're being squared, they get to leave the radical. So we can take out the m. We can take out the n, and we're left with the square root of n, and I can just clean this up is negative mn square root of n. I mean, really, I didn't have to put this there, but I wanted you to see that the numbers that are outside the radical have to be multiplied because they're all a product. Okay, so here's what I want to show you. I got the same answers, whether I used the square method, the factor tree method. Square, factor tree. Square, factor tree. And good night, Robadeer. 25 is 5 times 5, 25a. 2 squared, 2 times 2 is 4. There it is. So I'm doing the same thing, but one way has you looking at the square first. The other way has you doing the prime factorization. Okay, so let's look at number 4. Okay, so we want the square root of 50 a cubed b to the 4th. All right. 50, oh, just kidding. 50 is 25 times 2. 25 is composite, so I've got to break this down further. It's going to be 5 times 5. Both of those are prime. I go here to this other branch, and that's 2. So this is going to be 2 times 5 times 5. And yes, I totally have a different order, but my 6th grade math teacher was pretty awesome. So I'm going to do what she taught me, where everything goes in increasing order and then alphabetical order. There we go. Okay, now I'm going to start picking out pairs because they aren't really pairs, they're squares. 5 times 5, so 5 is a root. A times A, so A is a root. B times B, B is a square root. B times B, B is a square root. Now let's look at the leftovers. I've got a 2 left over. I've got an A left over. Now I just multiply, and I get 5ab squared times the square root of 2a. And there it is. Y'all, if I just made life easier for you, then I've done my job. All right, let's look at number 5. It's the square root of 90, c to the 4th, d to the 5th, e to the 6th. Okay. Dang, I keep forgetting. I'm using the prime factorization. Let's make a tree. Here, I am allowed to use 9 times 10 because I'm not concerned with squares. I'm concerned with finding the prime factors because from those prime factors, I can find my square roots. 9 is 3 times 3. 10 is 2 times 5. So this is the square root of 2 times 3 times 3 times 5. I'm going to bring in my C's. I'm going to bring in my D's. Good grief. I'm going to bring in my E's. Goodness. Don't ever tell anybody I did this, even though it's on video and it's going to be forever. Okay, let's pick our pairs. Let's pick our squares. Got a 3. I've got a C, C, D, D. Let's see. What did I say? I said a 3, a C, a C, a D, a D, E, 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 E. And then inside the radical are my leftovers. That's 2 times 5 times D. There's a leftover D. He's sort of forgotten. Okay, so I get positive or negative 3 C squared D squared E cubed times the square root of 10D. Okay, there we go. Whew. I'm working on these factor trees from 6th grade. Okay, if you like this way, please be sure to go back and thank your 6th grade math teacher. So I want the negative of the square root of 80z to the 16th. Oh, do I really have to write 16z's? All right, again, 80. It's okay for me to think of this as 8 times 10 because I'm using a different method where I just want to look for the prime numbers. 8 is composite, but it breaks up into 2 times 4. 2 is prime, so now I'm going to focus on the 4. 4 is 2 times 2. 10 is composite, but its prime factors are 2 and 5. So this is all right, because I know I'm going to need the space. Y'all know I'm going to need the space, okay? This is the negative of 2 times 2 times 2 times 2 times 5 times z, 2, 3, 4, 5, 6, 7, 8, 9, 12, 13, 14, 15, 16. Okay, there we go. All right. Gosh, this feels like a stretch Hummer. All right, bring down my negative. I've got a 2. I've got another 2. And then 1, 2, 3, 4, 5, 6, 7, 8. Spoiler alert, I saw this episode earlier. I know it's going to be z to the 8th. What's in the radical? Oh, just that 5. So this becomes negative 8 z to the 8th square root of 5. No. 2 times 2 is 4. My bad. And there it is. And these are the same answers that I got earlier. Here, 5a squared b to the times the square root of 2a plus or minus 3c squared d squared e cubed square root of 10d negative 4 z to the 8th z to the 5th. Okay, and there it is. 2 methods to simplify a radical.